Okay, today we're going to discuss about trunking protocol. Yesterday we discussed about VLANs and how do we attach a VLAN to a port. An attachment of a VLAN to a specific port is called access port. For example, in this diagram, we have a switch A. And on switch A, there is port 1. And there is a PC connected there. Okay, on switch A, port 1, the PC is connected, correct? So I wanted to put this VLAN 20. Okay, so when the frame comes in from the PC, when it comes to port 1, because we attached that to the VLAN 20, now it will broadcast to the ports. This is port 2, this is port 3, this is port 4, and this is port 5.
In progress.
So this is VLAN 20, meaning port 3 and port 4 are configured with VLAN 20. And this is VLAN 30. This is VLAN 40. So when the PC1 sends the traffic to port 1, because we attached it with VLAN 20, what are the ports it will be sending the traffic to, guys?
Switch.
What are the ports?
Port 1.
Yeah, port 1 already received it. Now what will the switch do with it? What ports it's going to send those packets to?
Send the packets to the port 3 and 4.
Yeah, it will send the packets to port 3 and port 4 because port 1, port 3, and port 4 are in same VLAN domain.
In VLAN 20. Okay, got it.
So the broadcast domain is used here to send to only this VLAN, right? So this is the concept of having a VLAN. Now let's talk about what is trunking. So before we talk about trunking, we need to understand what is a hypervisor is, or what is a server that will have multiple VMs is. Let's say this is a server. And let's say this server has 10 CPUs, 1000 gig memory, 32 gig RAM, and yeah, okay. So this server has this amount of capacity in terms of CPUs, memory, and the RAM. Okay, and hard disk, right? This is hard disk. We can call it as 1000 gig HD. Okay, and 32 gig RAM. Okay. So this server is like a big box, right? I wanted to separate this into multiple virtual machines. Okay, so I'm going to allocate some resources to this virtual machine, this virtual machine, this virtual machine, and this virtual machine. So for this, I can make 2 CPUs, 200 gig hard disk, 8 GB. 8 GB RAM. Okay. So we can call this server as the bigger box as the hypervisor. And the internal VMs, the inside VMs are called virtual machines, VMs. So if you consider this as a machine, you are separating them into 4 machines, which are called virtual machines, right? And this is a hypervisor. Okay. Now you understand the concept. Now let's talk about trunking protocol. Why did I mention this about trunking protocol? Now let's see that. Okay. What if this server is connected to a network switch? Okay. And for some reason, we wanted to allocate this VM to HR department, this VM to accounting department, and this VM to sales, this VM to marketing. So we are separating these VMs in terms of their requirements or their departments, right? So on the switch port, if I put this only in VLAN 10, will the requirement work? It doesn't, because every VM has their own IP and they are in different departments. So for example, this can be in HR, this can be in accounting, this can be in sales, this can be in marketing, right? So now I need to have 4 VLANs that need to be passed over this link, because I have 4 departments here. For example, if we consider HR as 10, accounting as 20, sales as 30, and marketing as 40. So I wanted to send all the VLANs 10, 20, 30. So all of these VLANs over a single link. For that, I need a trunking protocol. How does this can be achieved, guys? This can be achieved again with the VLAN header value that we discussed yesterday, which is the VLAN tag value. So when the frame is coming from the HR, right, they're gonna tag on their side with the VLAN tag value of 10. In the access port, the user does not tag their traffic with any VLAN tag value. No, they will not assign any tag on their side. We as the administrator will tag it on our side as VLAN 10 if it's an access port. They send it as like with no tag value. We attach that to VLAN 10 in a regular access port scenario. But here, the user has to tag their traffic with a specific tag value. And accounting team on their VM, they will tag with a VLAN of 20. And sales team, they have to tag with a VLAN of 30. Marketing team, they have to tag with a VLAN of 40. So everyone, when they are sending the frame out, they will tag with a VLAN tag value that they specify in their configuration. So when the switch receives the packet, it will check the header value of VLAN tag and will broadcast to that VLAN. If it receives the packet on VLAN tag 40, it's gonna forward that frames to VLAN 40. If it received it from VLAN 10, it will send to VLAN 10 ports. So based on the tagging value, and that is called 802.1Q tagging. 802.1Q. This is an IEEE standard name. So 802 means this is 1980. 2 means it's a month, February. 1 is just like index, like, you know, on that day, it has like on 1980 February 1, they started like doing A, B, C, so on like that. They started mentioning the 1A, 1B, 1C, similarly 2A, 2B, 2C. They are doing like an indexes from there. So it started, that's the naming convention there. And this protocol got the name as .1Q tagging. So this name is very popular. That's why I'm telling this, because this is just a name that is given to the trunking protocol. On the IEEE standard book, this is like the index that is given to that. Okay. And people just call, can you tell me what is .1Q tagging? They'll ask you questions like that. So then you have to understand that they're talking about trunking. So if you wanted to understand like in color coding, let's talk about, just to make it understandable, we're going to talk about, you know, the color coding of this. Okay, HR team is there, accounting team is there. So when the HR want to send the data, they will use a VLAN tag value of 10. Okay. So now consider the HR is sending the data on VLAN. Okay, there is this port, this port, this port. Okay. When accounting team is sending the data, that is on VLAN 20. So that is going to this port, and this port, and this port. Okay. So when the HR send the data, that means the packet is traveling with the tag value of, in this example, consider it as a red tag. Okay. So it's gonna send those packets to the ports which are on the configured with this red tag value, which is just the VLAN tag. Similarly, if the accounting team is sending the data, it will send the packets to the ports attached with the green tag, which is VLAN 20. So on the HR side, on the accounting side, it's their responsibility to tag with whatever we tell them to tag. Okay, if a user comes in and asks me, hey, I'm in specific location and I'm coming from different HR department, you know, what should be my configuration? Okay, so your IP should be, your subnet mask should be, your gateway should be, and your VLAN should be. So I'm going to give these details to that server team, and on the server team, when they're building their HR machine, they will use this information to build that VM. So automatically, when they send the traffic, I know that the traffic is coming from this VLAN tag of VLAN 10, and I'm going to forward that to all the HR ports. Any questions there on trunking, guys?
So just can you tell me if I understood right or wrong? Like trunking means like using the color coding and the VLAN headers separating the virtual LAN ports. Is that right? Did I understood right?
No, color coding is just an example I gave to you. It does not use the color coding. It
Okay.
just uses the VLAN tags.
Just uses the VLAN tag. Basically, like exactly what we spoke yesterday is same thing, right? At the end of the class, like you explained about the VLANs and all, it comes under trunking, right? Or there is a
No.
major difference between these two topics?
There is a big difference. That is an access port. This is a trunk port. So when an access port is connected, so this is only one PC. It's like a one machine. Okay. And when they send the frame, they don't tag any VLANs on their side. They do not tag it. Okay. They send it as a normal frame. When it received by the switch will attach the VLAN tag value of 10 because we as administrator configure this as VLAN 10. Okay, this port as VLAN 10. And we're going to forward that to the port which is configured with VLAN 10. For example, this one. And we don't do it because this is a different VLAN tag. So this is the concept of access port. In the trunk port, instead of we tagging it on our end, the HR team will tag it on their side of VLAN 10. So when it comes to us, because it is tagged with VLAN 10, we know that it should be forwarded to the ports on the VLAN 10 only. On a single link, multiple VLANs are transmitted. On a single link, only one VLAN is transmitted. Do you understand the difference now?
So in access port, the switch will configure if it is an VLAN 10 or VLAN 20. In this, we itself configure it if it is a VLAN 10 or VLAN 20. Did I get it correct at this time?
Yeah, but the major understanding you should get is trunk port is allowing multiple VLANs on a single link.
Okay. Okay. So in access ports, we can't do that in a single line. We can't do, right?
No, we cannot.
Okay, understood. Thank you.
Any other questions?
No, sir, it's clear.
Okay, Sumant Reddy, can you tell me what is an access port and why it is used?
So we use it if we want to send the information within the one link to switch.
Answer is not clear. Can you try one more time? What is an access port and why it is used? Harshavardhan, can you try? What is an access port and why it is used?
It is used to control the traffic, sir. Like a lot of users in the VLAN. Is it correct?
No. Deepak, can you try? What is an access port and why it is used?
We use the access port for sending the single VLAN to the to the specific one from ours.
Okay, yeah. So an access port, it is used to attach a single VLAN to the port. On the user end, they don't tag any VLANs. They will send it as a plain frame. But as a network engineer, our responsibility is to tag with a specific VLAN, and we will forward, and the switch will forward that packets to the other ports in the same VLAN, right? But as a user end, they don't tag with any values. It is a single port with no VLAN associations on their side. But when it comes to our side, we attach with a single VLAN value. Okay, that is correct. Okay. Riteshwar, can you try what is a trunk and why it is used?
So can you repeat the question once again?
What is a trunk and why it is used?
Uh,
Nitin, can you try what is a trunk and why it is used?
Yes, sir. Trunk is used for VLAN where data packet is marked for where for identify the specific multiple VLANs and transmitted the physical connection, I think.
Can you elaborate?
Means it is used for the mostly for transmitting the data and
What do you mean by transmitting the data? I'm not getting that. What do you mean by that?
means if you want to send a packet to only in a switch through for different switches means in a switch they are different what do you call switch one switch two like that. So if we particularly mention that VLAN is there means we can only send through that one, sir.
No, it's not clear, Riteshwar. Let's move on. Anyone else?
It is
We
a
can,
It uses
okay.
multiple VLANs to make connections from the PCs. So if a PC sends a connection to the switch, which is in VLAN 20, so it connects in a different VLAN. Like it, if the channels are in 3 and 4, which is in VLAN 20, so it gets connected. If I'm
But
correct.
what is trunking there?
Sir, sending multiple VLANs over a one physical.
Yeah, so trunking is sending multiple VLANs on a single link. When we have multiple virtual machines on a server, or when we have a hypervisor with different VMs on it, when it is trying to connect to a switch on the server end, they're gonna tag their VMs as a VLAN tag value, and they're gonna send the traffic on the link with a tagged VLAN, and that sending is called trunking. So allowing multiple VLANs on a single link is called trunking. Okay. Most of you guys are not able to answer the question. So that means that either I am not explaining the concept properly or you are not guys paying attention. So we need to correct that. So please pay attention or share me a feedback where we are lagging on that, so that we can collectively improve why we are not able to focus on the class. If it is on my end, please let me know. I will definitely try to take some corrective actions and then try to improve. Or if it is something that on your end, please make sure you correct it yourself and give your best to the class. Okay. Let's move on to spanning tree now. So switch A is connected to switch B is connected to switch C, and switch C is connected to switch A. So we know that this will cause a loop. What is loop actually, right? So if switch A says that, hello, my name is switch A to switch B, if switch B passes that information to switch C, and switch C is passing the same information to switch A, so then switch A is sending a message, right? Again and again. So there is a loop happening here between the packets. What happens if there is a loop? The switch B will learn the MAC address of switch A from port 1. And switch C will learn that same MAC address from switch A, and also switch B sending the same frame to switch C. So now switch A MAC address is learned from this port and also this port. So switch C will continuously doesn't know which port to send the traffic to or where the destination lies. So the CPU, the brain of the system, gets confused because there is so many flaps. Think about there are like 20 lakh packets that are looping continuously. So the hardware cannot handle that loop and the switch will completely go down. Sometimes what you will see, your PC is getting so slow. When you open multiple windows, you have to close some of them. You will go to task manager, you will close some of the programs, right? Similarly, if there is a loop, the switches cannot handle that loop and they're going to shut down state, right? They'll go to shutdown state. So to avoid this, we need the spanning tree. Okay, spanning tree is used to avoid the layer 2 loop in the network. So when a frame is coming from two different places, when the same frame is coming from two different places, for example, on switch C, the same frame is coming from switch A and the same frame is going to switch B and coming to switch C. Right? So there is a loop here between these two ports. So when a same frame is coming from two different places, there is a loop in the network. We have to avoid that loop. And to avoid that, we use spanning tree. So spanning tree is used to avoid the layer 2 loops in the network. Okay, so now let's talk about how the spanning tree will avoid that loop. switches will talk between them using a message called BPDU. So when the switches connect in the network, when switch A, switch B, and switch C are connected in the network, they all communicate using a message called BPDU messages. What is BPDU? BPDU is bridge protocol. So switches will communicate between them using these BPDU messages. Okay. So what does the BPDU message contains? BPDU contains so by default, the priority values will be so when switch A send a message to switch BPDU message to switch B, it will attach the priority. They both see what is the priority of both the devices. Okay. Let's say I configured my priority as 200. And I configured my priority as 300. I configured my priority as 400. Okay, so switch A and switch B will talk, switch A and switch C will talk using these links, and they exchange the BPDUs and they exchange the priorities inside of it, right? So now switch A will say my priority is 200 to switch B. Switch A will say my priority is 200 to switch C. Similarly, switch B will say my priority is 300 to switch A. Switch C will say my priority of 400 to switch A. And switch C will say my priority is 400 to switch B. Switch B will say my priority is 300 to switch C. They all exchange the BPDUs. So now, whichever has the lowest priority, that one will become the root bridge. Root bridge. Okay. So what is root bridge, guys? Root bridge is the switch which will be putting all the ports in the forwarding state. It will have to have sending the frames in both directions. So that is what the switch A will do. Okay, so that because the priority is lower, let's change the color. So this one will become the root bridge. Root. Okay. So now it has to forward the frame in this direction and also in this direction. Okay, now switch B and switch C, they both exchange the priorities, right? So switch B has the lowest priority of 300, then 400. Now switch B will forward that frame to switch C. And now switch C will put this port in the blocking state. Okay. So we avoid the loop. Switch A can talk to switch B. Switch A can talk to switch C. If switch C wants to talk to switch B, it has to pass through the switch A. And switch span tree put this port in the blocking state. And these states we will talk about more about the span tree states now. But switch A will be in the forwarding state by allowing the traffic. So to avoid the loop, span tree will exchange the BPDUs, and whichever has the lowest priority, that one will become the election. But what happens if the priorities are same? If all the priorities are same, like 3 to 600 by default priority, if we don't configure any priorities, right, then the MAC address will come into the picture. Whichever switch has the lowest MAC address, that will win the election because the priorities are all equal. What is the MAC address, guys? What is a MAC address?
It is a
record
which
Given by a vendor, like unique number to the system.
Yeah, so it is a unique number given by the vendor, right? So on the switch A, that is a unique number. So there is no chance of switch A, switch B, and switch C having the same MAC addresses. It is a unique number. So every switch will have its own MAC address. So whichever switch has the lowest MAC address, that will win the election. So our problem is resolved. So we can have avoidance of the loop with the spanning tree, with the exchangement of the BPDUs. They all exchange the BPDUs, and whichever has the lowest BPDU, that will win the election in terms of forwarding the frames. Any questions, guys?
So one question, sir. So switch A has the lowest priority with 200 and B has 300 and C has 400. C is blocked. You can't send message directly from B to C. So why will 200 send message directly to 400? Why shouldn't it send to 300 instead?
I'm sorry. Why will it send to 400 instead of 300? Okay. Let's say the destination is here. For example, a PC is here. Okay. Will the switch B know how to go to this destination?
No, it should send a message directly to C and C sends to the PC.
That is why it sends to switch C. So in this case, to avoid the loop, it knows a path, right? But what if PC wants to talk to PC here? PC A wants to talk to PC B here. It cannot go directly via this link because this link is blocked, right? It has to go all the way to root and it has to go back to this PC. Is that clear? Or did I misunderstood your question?
Yes, sir. It's clear. So to talk to the PCs, it has to go to the switch first and go to C to A to B, and next to the PC, right?
Yeah, like that, yes. That is how the workflow is, yes.
Sir, can you explain why is this link is blocked like B2C once again?
It is blocked because switches exchange the BPDUs, and whichever switch has the lowest priority, that one will become the root bridge. In this case, switch A became the root bridge. So the ports connected to the root, let's undo some things here. Okay. So the switch A port priority is 200. So whatever the ports that are on the switch A, they both need to be in the forwarding state because this is the root bridge. Okay. So now switch B and switch C will talk between them and they exchange the priority. So whichever has the lowest priority, that one will be in the forwarding state. But the highest priority one has to block the port. So that is why it's blocked.
So if there are PCs near switch C, so if switch B want to connect to switch C, so will that be a like time taking process?
It has to go through
or
it has to go through the route.
It takes like more traffic to come from B to A and A to C to the PC, right, sir? Is there any different way, or it's the only
You're
one?
saying more number of hops, you're saying?
Yes.
Well,
Since the B2C route is blocked because of the traffic. So if there
yeah,
are
I understand your question, but to avoid that, there are different ways. For example, there is an, per VLAN spanning tree. You can also do like load sharing between the links. There are different methods to bypass that, but we'll talk about them when we talk about the flavors of spanning tree. This is a first version of the spanning tree, which not have any advanced features. Okay. But when we talk about per VLAN spanning tree, then we will discuss about how we can use this link as well. Okay.
okay, extra links, got it, sir.
So who decides the priority?
You decide it. You as a network engineer, you decide it. If you are managing this network, you will decide which can be your route.
Okay.
Okay, now let's talk about the port states here. 1 second. Okay, so now let's say the priority is 100 here, 500 here, 300 here. Okay, this one will become our route, right? Because it's the lowest priority. And this one will be in the forwarding state. This one will be in the This one will be in the forwarding state. This one will be in the forwarding state. And the link between switch C and switch A, this link, this one will be in the blocking state. Because of the highest priority sits here. Second lowest priority is this one. So this one should not be in the blocking state. But still, it is blocked. Okay. What are the ports of the route, right? So the ports of the route are called designated ports. Ports on route are called designated port. The ports that are closest to the ports are called, the ports that are closest to the route are called route ports. Okay. In this case, ports that are closest to the route are called route port. So in this case, what will be the route ports? This one will be a route port because it's directly connected to the route bridge. This one will be a route port because it's directly connected to the route bridge. So this is called designated port. And this is called designated port. This is called designated port, route port. And this is called route port. Did you guys understand the difference between designated port and route port?
Yes, sir.
So the ports that are on the route bridge are called designated ports. The ports that are closest to the route are called route ports. Okay. and the port that is blocked is called blocked port, right? So whichever port that is called blocked, that is alternate or blocked port. I mean, we can call that as alternate or block ports that are blocked are called blocked or alternative. Any questions? Yes. Until here, no questions, right?
No, sir.
Okay. With that, I'm gonna stop here. We'll talk about the flavors of spanning tree tomorrow, like what is rapid spanning tree, what is a per VLAN spanning tree, and what is multi-spanning tree tomorrow. I'll stop it here and I'll leave the floor for any questions. I'll stop the recording.